All right, so now we're back with another 15 minutes of free video time. And oops, where am I? We were about to work on making the histogram for the TV minutes variable, which was our TV hours video, TV hours variable multiplied by 60. And we need to put in a title. So we're going to do distribution of TV minutes per day, and then for our X variable, let's say TV minutes per day. Again, note how when we were making our histogram for TV hours, we had a bin width of 1. And when we're looking at minutes, we have a bin width of 60. There's 60 minutes in an hour, so we are going to adjust accordingly. And we are making that same vertical line. And this time we're doing it at the mean of TV minutes rather than TV hours. So let's do this. Okay. So let's look at TV minutes per day. Is the shape the same as TV hours? Yes. But the axis is not the same, right? This is going from 0 to 24, 25 hours across the bottom. Over here, we're going from 0 to close to 1,500 minutes per day. So they're being measured in different units, but the overall histogram is the same. It has the same shape. The mean is at the same point in the distribution. Okay. Another kind of adjustment you can make to a variable is looking at how far a variable is from the mean. So creating some new variables where instead of the actual values, we have the difference from the value to the mean. And this is sometimes called centering or recentering a variable. You take the variable and subtract the mean from it. We'll do that, then we'll get the standard deviation and histogram for those as well. So we are creating a variable called TV hours 0, and it's equivalent to our TV hours variable minus the mean of TV hours. So for example, we said the mean of TV hours is about 3. So for each person in our distribution, we're taking their hours of TV watched per day and subtracting 3. Somebody who watches 10 hours is going to have a value for TV hours 0 of 10 minus 3 or 7. Someone who watches only 2 hours of TV is going to have a TV hours 0 video of 2 minus 3, which is the mean for a TV hours 0 value of -1. We're going to make that variable. We're going to get the standard deviation. We're going to make a histogram. So, title, distribution, did I spell that right? Distribution of centered TV hours. Again, centered TV hours. Okay, so again, we have 2 boxes. This is mostly errors, but it does give us the standard deviation, which is 2.3648. And then this is our histogram. Notice the overall shape is the same, but notice now instead of the mean being at nearly 3, which is what it was for our original TV hours variable, the mean is now at 0. This is because we subtracted the mean from every value in our distribution. Centering it means subtracting the mean. And so this is how it looks for TV hours. Now we're going to do it for TV minutes. The same idea. For each value of TV minutes, we're going to subtract the mean of TV minutes to center our distribution. And so the title here could be Distribution of Centered TV Minutes, and the label Centered TV Minutes. And let's run this, see what we get. We got a standard deviation of 141.888. And we have our histogram. And again, the shape is the same. The placement of the mean is the same in all of these histograms, but where they begin and end is different. So here, again, the mean is at 0 rather than at what we got for our mean value for TV minutes, because by centering, we're subtracting the mean for TV minutes. Why is subtracting the mean from each value sometimes called recentering? When we subtract the mean, we are centering all of the values of the variable around the mean. What does a negative value on these variables mean? So, for example, centered TV minutes, you have some people on the left side of 0. They have negative TV minutes. Same thing up here for centered TV hours. There are some people whose value on centered TV hours is -1, -2. Why? A negative value means that the original value is less than the mean. For example, someone who watches less than the mean hours of TV per day will have a negative value for TV hours 0, okay, which is our name for the centered variable. Describe how the standard deviations for these recentered variables compare to the standard deviations for the previous variables. Okay. TV hours, which is what we began with, had a standard deviation of 2.3648. Centered TV hours, 2.3648. TV minutes, oops, did I not get the standard deviation of TV minutes? Oh, there it is. TV minutes, the standard deviation is 141.888. Centered TV minutes, 141.888. The standard deviations are the same whether the variable is in its original form or if it is centered. Centering does not affect the standard deviation. So why are we doing all this? Well, one, when you're working with really theoretical material, like we have been for the past couple of weeks, it's hard to come up with interesting lab ideas. But secondly, what we're doing here with converting units and looking at it, whether it changes the shape of the distribution, which it doesn't, or changes the standard deviation, which it doesn't, but it's just different ways of having our data measured, different units. When we do that, that is analogous to a procedure that we do when we're doing our inferential statistics. We're looking at whatever our sample statistic is, but then putting it in the framework of that standard normal distribution and looking at where it falls, what the probability is we would have gotten a mean like that if the population mean was some value that we predicted. We're converting our variable. So you can convert it by subtracting the mean. And another thing that you can do is you can subtract the mean from a variable and divide it, what you get, by the standard deviation. And that is what a z-score is. When you take an observation, subtract the mean, and divide it by the standard deviation of that variable, it's a z-score. It's a standardized unit, so you can compare it across different variable types, meaning TV hours as compared to age, as compared to something else. And it allows us to work with the standard normal distribution and all of the properties that that distribution has in terms of helping us make predictions for inferential statistics. Whether or not this made any sense to you, you're now done with the lab, so that's always good news. We want to make sure to save our lab. Oops, let me click save, and then we're going to knit it. So do knit to Word. Assuming I have no problems, it's just going to run. You can check the progress down in the console area. You can see right now it's chugging along. If you ever get an error message down here and it stops knitting, look at what the line number is where it gives you the error message, and then go back up to your notebook and find that line number and see if you can figure out what went wrong. It might be something just like punctuation or extra tick marks, but that's your clue. When we're doing the knit, it's knitting everything from the very beginning of the semester to now. So it's a big, long document. So you're going to download your file, and then you are going to go back into the week by week and week 9. And we have on this main page, whoops, upload your knit Word document here. So just click that, and you have until Friday the 24th to upload your knit Word document.